Welcome back, students. In today's class, we would be studying how to integrate tan x with the root on it. So foremost, to integrate integral of root of tan x, we would be making the following substitution, which is u being equal to root of tan x. Now, squaring both sides, we would get u squared being equal to tan x. Now, if I were to differentiate this u squared, I would get 2 times u du. Differential of tan x is secant squared x dx. So there is a formula for secant squared x, which is secant squared x being equal to 1 positive tan squared x. I'm substituting that formula. That's going to be 1 positive tan squared x times dx. But u is root of tan x, so that would mean u squared will now be tan x. So substituting the value for tan x, I would now have 1 positive u squared raised to the power 2 times dx. On the left, it's going to be 2 times u du. But I need to substitute for dx. So I would be rewriting this as 2 times u du over 1 positive u raised to the power 4 being equal to dx. So the original integral now can be rewritten as integral root of tan x dx is now being equal to integral 2 times u du divided by 1 positive u to the power 4. But root of tan x is going to be u, so that would mean I would now have a u squared. So I would have to integrate this quantity. So what I'm going to do is I would foremost divide the integral by u squared. So that would mean I would now have 2 times u squared divided by u squared times du over 1 over u squared positive u to the power 4 divided by u squared. This can be rewritten as, in fact, the u squareds can be cancelled, giving me 2 times du divided by 1 over u squared positive u squared. Now, this quantity in the denominator which you see can be represented by 2 ways. So that would be done as follows. So I've got u squared positive 1 over u squared. I can rewrite this as u positive 1 over u raised to the power 2. Of course, I would have a positive 2u times 1 over u that has to be subtracted, which can be rewritten as u positive 1 over u raised to the power 2 negative 2. So this is one way of representing u squared positive 1 over u squared. There is another way. That would be writing u squared positive 1 over u squared as u negative 1 over u raised to the power 2. Again, I need to add 2 times u 1 over u, so that the term that arises here, which is negative 2 times u 1 over u, can be cancelled with this. So rewriting, I now have u negative 1 over u raised to the power 2, of course positive 2. So 2 representation for the same quantity. So now what I'm going to do is I need to integrate this, right? So let's do that. 2 times du divided by u squared positive 1 over u squared is now rewritten as 2 times du divided by u positive 1 over u raised to the power 2 negative 2. So this is the first representation I'm using. Now, if I were to have the differential of the denominator in the numerator, then it's simple. But we don't have it here. You have to note that the differential of 1 over u, positive u, is 1 negative 1 over u squared times du, if I were to differentiate this. So I need to somehow bring this over to the numerator. I would be rewriting 2 times u du divided by u squared plus 1 over u squared as integral 1 negative 1 over u squared times du divided by, if you would remember, I have a form for this, right? I have written this as u positive 1 over u raised to the power 2 negative 2. Now, if you differentiate the denominator, you can see that you have this quantity 1 negative 1 over u squared. So the additional term is 1 over u squared with a negative sign, so I have to get rid of it. So the way I'm going to get rid of it is I would be having 1 and then adding 1 over u squared times du, and then writing the another representation for u squared positive 1 over u squared, which would be u negative 1 over u raised to the power 2 positive 2. So see the numerator, it's 1 negative 1 over u squared positive 1 over u squared. So all these things can be cancelled, giving us the 2 back, which we have here, right? So that is why these forms are very critical to be understood. So now the challenge is to integrate these quantities. So consider 1 negative 1 over u squared times du divided by u positive 1 over u raised to the power 2 negative 2. So if you were to take u positive 1 over u to be as t, then differentiating this quantity would give you 1 negative 1 over u squared times du is equal to dt. So you can substitute it there, and that would give you dt divided by t squared negative 2. Now there is a formula which states that integral dx divided by x squared negative a squared is equal to negative 1 over a hyperbolic tan inverse of x over a. This is the formula I would be using. So if I were to use this formula, this would be negative 1 over root 2 hyperbolic tan inverse of t divided by root 2. Now we got to integrate this quantity. So to integrate this, I would be using the substitution, let u negative 1 over u be equal to t. When you differentiate this, you get 1 positive 1 over u squared times du. That would be equal to dt. So replacing, you get integral. For the numerator, you got to replace it with dt. For the denominator, is going to be t squared positive 2. Now there is a formula which states that integral dx divided by x squared positive a squared is 1 over a tan inverse of x over a. So using this, we would now have 1 over a is actually root 2, tan inverse of t divided by root 2. I'm not placing the constant now, I would do it towards the end. So rejoining the two, now have negative 1 over root 2 hyperbolic tan inverse of t divided by root 2 positive 1 over root 2 tan inverse of t divided by root 2. For the first quantity, my t value has to be replaced, so negative 1 over root 2 hyperbolic tan inverse of my t is u positive 1 over u divided by root 2. For the second quantity, my t is taken to be as u negative 1 over u. So replace that. So that would give me tan inverse of u negative 1 over u divided by root 2. But I have taken u to be as root of tan x, right? So substituting the value for u, we would now have negative 1 over root 2 hyperbolic tan inverse of root of tan x positive 1 over root of tan x divided by root 2 positive 1 over root 2 tan inverse of root of tan x negative 1 over root of tan x divided by root 2. Now of course you can simplify this. You have to add the arbitrary constant c also. You are free to simplify this and write the simplified fashion, but as for me, I think I will stop here. I'm happy to have this as my final answer.